All right, today we're basically going to work on Lab 7 machinist hammer handle. We're going to write the program for it. So I pretty much opened all these files, not the video, because the videos of the drawing. I opened the rest of them. So a little bit of a review here. So we're making this hammer, and we're focusing on the handle. The handle's too big to fit in the lathe and do one pass, so we have to flip it over in the middle of it. So that's why we have a part 1 and part 2 on our drawing. So you should have had this drawing done already. If you don't, make sure you get it done, of course, and it needs to look like this. Exactly. I think there was one dimension over here that might be a couple thousandths difference on the way we did it in the video, but it won't make any difference because it's on a rough cut. All the rest of the dimensions should match. We're going to work on part 1 first, okay? This end will be in the lathe, and then we'll basically are going to machine from right to left, okay? And then we'll basically put an M0 and some shutdown and startup codes in there. And they're actually written in the instructions, okay, right here. Okay, we'll put them in there, and then we'll start programming from right to left on the top half. Okay, remember you had to move your UCS up here, so this should be 0, 0 right there when you're doing it. Little review on circular interpolation. Remember on a lathe, it's kind of the opposite. G2 is counterclockwise, the opposite of a clock.
Thank you.
Did it work?
No, I ended up having to get Michael.
Okay, good. I'm glad you got it work. This is G2 is counterclockwise and G3 is clockwise on a lathe. It's the opposite of a mill, okay, because the slant bed lathe was developed later than the laying flat one. If a laying flat lathe, which nobody even uses anymore, is actually the same as a mill, but so pretty much on a mill or lathe, it's always this way. Okay, that's the only thing you really need to remember. And remember that whenever you type in G2 or G3 codes, it's just like G1. You tell it where to go, and then you just add the radius behind it. On a lathe, there's really no, there's almost never a radius that would be over 180 degrees, because you'd basically be cutting a part off, okay, because remember you're doing the top half of it. Okay, so over a half circle would literally cut it off. So it's very rare. So you can always use radius program. You really don't have to use IJK. Okay. Remember, IJK goes to the center point. You'll see that with automated software. It'll write the IJK without the radius usually. It's a little easier to program that into the CAD software, so that's kind of why they do it. All right, so back to the handle. I'm going to do a split screen here. Okay, and then we're going to open up the lathe. So CNC base. Okay, and it did open up my last program, it looks like. So we're going to have to do some setting changes on this thing so they can write it. So you're going to want to open that workspace. Mine, since I'm doing it on my laptop, it automatically opens up, and if you're using your own laptop, it do the same. It opens the last program you did. Okay. But it does not do that at school, so you're going to have to open up the let's go back to assignments. You got to open the workspace for the lathe, not the mill. So it's probably on lathe template, maybe. Let's just see, lab 6. Nope.
One of the very first labs that you had us download the
So test run, maybe, probably. Yep, there it is. Okay, so if you haven't, you should have put that on your U drive, but just in case you didn't, go get it. I'll show you how to do it just in case you didn't. So you basically hit that, and it should download into your computer on downloads, and then you go over here to File. I'll close this one that was already open. Go to the File, so yours should look like this. You go to Open Workspace, not Open, right? Open Workspace. And then you go get that thing. Mine went to downloads. Yours probably went to the same place. I think it did anyway. There it is. It's like I've done it before. And open it, and it should set everything up. Shuts it down. Close. Now notice we're doing typically a 3/4 by 3 inch long piece. Well, we're not running that anymore. Okay, so the piece is not 3/4 by 3. It's a lot bigger than that. So we need to go ahead and put it in there to the correct size. So we're going to fix that right now, if I can remember how to do it, that is. Okay, so we go to drawing, and I know it's 1 inch diameter. I think it's 11 1/8. So I'm using Control+ to zoom in on my drawing here, Control minus, and I'm scrolling. So yeah, it's 11 and a quarter long, okay? So we're going to make 11 and a quarter long. Okay, and 3/4 is sitting inside the machine, so we got to remember that. Okay, and our 0 will be at the end of the part. Okay, so we're going to go to setup. Hopefully everybody's got this open. And run settings or verify settings. I think verify settings. Yep. Okay, so verify settings, which you could have also done it by hitting that little button there. And let's go to stock. Now this is just so the picture looks right. It really doesn't affect how it actually runs, but of course if you program it for a 1 inch by 11 and a quarter inch piece and you've only got a 3 by 3/4 inch piece in there, it's going to be moving the head over nothing. So you want to go ahead and fix it. So really, like I said, it doesn't really affect your program. It just affects the visual of the virtual machine. Okay, so we switch stock to instead of being the length of 3, we switch that to 11.25. Okay, and you would do this for anything. If you're doing anything custom programming, you would, that's what size you'd put in there. And we did this, I think, maybe in the very beginning. We're going to be doing it on the mill more. So 11 and a quarter for the length, and the diameter is just 1. I think everything else is the same. 0, 0, initial tool position. That's just where the tool is going to start out. It makes no difference. The 0, 0 is important, okay? Because if you're programming it from, like, say, the right, you would switch the origin over to, like, maybe 4 inches over or something on the z-axis over. Remember, this is z, okay? And a lot of times you would do that. So, and then again, it doesn't really affect the program. It just affects what you see when you're a virtual machine. I don't think we're doing anything else. And you can do some different things there. You can change colors around, you know. Doesn't hurt anything if you want to change the stock to maybe more like that, so it looks like aluminum. So that's it, okay there. Okay, now it should be gigantic. Now we're only programming the first, 4 inches or something here? Let's see here. That's part 2. Yeah, 5 inches. So you really don't need to see the whole thing, you know. So you don't need to make this thing gigantic. I mean, you could, but you don't need to. You will have to make it bigger so you can see some of it later. Okay. Use your arrows to move things around here a little bit. But you're only going to need to see. Big pain in the butt, isn't it? Wrong way. Okay. We've got that all set up. The tooling should be set up correctly from the workspace. So we don't have to worry about that. All right, so we're ready to program. So we're going to come in right here, okay? And we need to come in above the part so it doesn't touch. Now, I already have that kind of set up. This is an extruded piece, so it's extremely accurate. A lot of things you buy for lathes, unless they're hot rolled steel or wood or something like that, they're going to be extremely accurate. So you don't necessarily need to be 1/8 of an inch above it, all right? So I think I set this up to be just 10/1000ths above it, and that's plenty. Okay, it really is. It should be within 1/1000th of an inch or less. A lot of these are within 1/10,000th of an inch diameter. So we're going to start out at 510, which is above the part, and we're going to go ahead and start out at 4.75 and go straight down into the part there, and then do a bunch of, then start cutting all this blue out one at a time. Okay. And they're all 40 thousandths drops, so you probably can memorize them. It's 0.5 right here, 0.46, 0.42, and then we'll do a loop to cut this out. I think this is just barely more than 40 thousandths, but hardly any, maybe 41 or 42, so we're just going to loop cut it out all the way across to this. So the plan is come down to here, okay, to the very top there. Mouse ain't showing up the best, but to the very top there to 5.1, 4.75. Let's see, the X would be first. Yeah, so 0.51, 4.75 in the Z. X is up and down. Remember, Z is left or right. And then we're going to go down to this with a G1, okay? And then we're going to start cutting across and then back up 10 thousandths to this and then diagonal down straight across with a G1, back up 10 thousandths with a G0. And then we'll do a G, this is clockwise, so that'd be G3, all the way over to here. Or to this one, I guess. to here and then back down. Notice our numbers on the bottom are on the part, and our numbers on the top are on the rough cut. So we're only going to be looking at the ones on top to start out with. Just ignore all these except in the very first position. Okay. It looks like there is a number in here too, so we'll have to make sure we come down to 4.747 be in the right spot for that. Okay, almost messed that up. All right, so let's go ahead and go to the instructions here and start programming. Going back to lab 7, which is probably past due since it's a long project, so that's okay. It's not really due till we get it done. So we did the drawing last time, programming this time. Okay, so we're going to start out with our, hopefully you have a template. I'm going to open mine up. If you don't, you just retype in your semicolon, your name, part number, and so on. Part numbers were given to you in the first mill project. So, so let's see if I can find my template here. I think I've got one. Bare lathe template. Hey, look at that. I've got it all done. So put your name, the correct lab. This is lab 7. Up, you got to go to edit, unlock it. Okay. Lab 7, hammer handle, all caps. Just turn your caps on when you're doing these kind of things. Pretty much in AutoCAD and that, you can typically do that. The date is 3/18. And make sure you put your part number in there. If you know it, you can come back and add it later if you don't. It's got to have M201 in there first so that it homes correctly. And then remember, our backslash tells the virtual machine not to home, so we're going to hit the optional skip on the virtual machine. So don't forget your backslash, or it won't look right when you do it. And then this is sets our 0 position. Okay, that's how far it is from this part reference 0 right there, that little thing, all the way up to where the machine thinks 0 is. And that way we can say, okay, I know you're up here and you think this is 0, but I'm moving you down to here, and that's where I'm going to program from. Okay, so it's 2 inches, 2.213 down, and 6.705 up on that machine. And every machine will have a different number for that. All right, M3 S2000 turns the tool on, 2000 RPM. Okay, this is our start position right there, so we're ready to program. And we're going to program that whole thing, and then when we get done, let's see if there's anything else I say in here. Finish cuts are 5. I think we might have done 10,000s, but it's all fine. And G1, G2, G3s, so on. Be sure you have plenty of X clearance on the finish. Oh, when you return from finish cut, make sure you have plenty of clearance, so you go up to 2 and 4. That way you get enough room in to get your handle in there and spin that part over. And the spindle's off. So these codes are very important that you put these in here, okay? All right, as long as you get them in there, you'll be fine. So we'll program the first part, add this, and then we'll program the second part. And then next class, we will do the threading. Okay, I think I got that half memorized. Okay, these are just sample programs. Okay, you don't have to do anything with these. They're just kind of programs I put in there in case you're confused about how to do it. But with the video, you probably won't need them so much. We're going to be doing most of it together. So a little bit of extra study work, you can look at those samples. It's very important you do this right, because we will be making this hammer, and this hammer is everything our little educational lathes, which are 100% real manufacturing lathes. They're just miniature versions. It's everything they can handle. So if you do something wrong, you can easily tear something up. Okay, it's about as big a part as they will run. So, and it takes everything they've got. So you got to be really careful to program it right. So if something looks wrong on your virtual machine, it's probably wrong. Definitely before you turn in this file, if you're doing this online, you definitely need to watch the virtual machining. And you should be turning in a video for that if you're doing it online as well. Okay, so we're coming to right here, this 4.747. and 5.1. So let's go ahead and do that. So the first one is a G0. Okay. And I've already got that in my beginning here in my template. So the first X position is 0.51 on this one. Okay. You could put 0.51 and 0, it wouldn't make any difference. So it's up here a little bit high, 10 thousandths above the part. And then the Z, got one space over, like I had two, which really wouldn't hurt anything. And then my Z is 4.747, okay? 4.747. And you could put 4.75 there, it really wouldn't make any difference, but then I'd have to type another new Z in here. Why do I have just Z on there? I don't know. This is a template, so that's why. Okay, so next thing I'm going to do is go straight down to the X of value of 0.5, which will be right on that part. Well, I'm sitting up here. I can go straight over to here, actually. All right, yeah, so I'm going to go down to this diagonal and then go straight across. I wish I had a pointer instead of that or I-beam there. All right, so we're going to go to G1, okay, just like I've got there, and the X value will be 0.46, okay, because we're going to drop 40 thousandths into the part. Okay, so I know it's 50 thousandths and 5.1, but it's really only 40 thousandths into the part, okay. And then the Z value is right here, okay, it's 4.649. And if I say a number wrong, somebody yell at me. Or if I type it wrong, 4.649. Okay, so now we're sitting right here. Okay, now we're going to go straight across and cut all that blue off till we hit over to there. All right, and we did go on F6 there, so we set our speed. And you always want to do that when you start out, because I mean it won't be the right speed if you don't. So this first cut, so we got to tell it how fast to go. First rough cut is going 6 inches per minute over. Okay. Okay, now this one we don't have to put a G1 because this is still G1. We're just going straight over. And we're going straight over here to the Z value of 3.851. So that's just a Z of 3.851. And it's real easy to mix up your X's and Z's. I still do it just because I've been doing CAD my whole life. And this is not Z to me, it's X. But programming a lathe, that's Z. Okay, so we went straight over there. You could put G1 on there, it'd still work, but you don't have to because you already did. And programming is what they call modal, so it remembers what you did. We don't have to put speed on there either. All right, so now we're going to go back at high speed. So that's a G0, not a GO, G0. Okay, and we're going back right to where we were before, but 10 thousandths higher. So I don't even really have to look at the drawing. It's just 10 thousandths more. So X 0.47. It's going to go up 10 thousandths. Okay, and the Z is the same Z as it was before. We're going right back where we were. So Z 4.649. So I'm just looking at my lines up here, okay, and I'm just retyping those, but 10 thousandths more on the X, right? That puts me up high. And it will drag on the part a little bit, but not very much, just for a little split second. You don't want to go straight back, because if you went straight back, it's actually machining and it'll wear down your tool. So, and it'll leave a bunch of little zig marks, which don't really hurt anything on rough cuts, but it will wear out your tool a lot faster. All right, so now we're basically sitting 10 thousandths above, so now we're going to go down to this one at a diagonal, okay? All right, so that one is, and that's cutting. So it's a G1 again. And it's 40 thousandths less, so I can just, it's kind of memorized, right? It's 40 thousandths less than 4.6, so it's X 0.42. Okay? And the Z value is whatever that says there, 4.542, 4.542, okay? And I'm just going to do this first one for you, and then you guys are going to have to do all three of the other ones, okay? On your own, and hopefully you get them right, so don't make any typos. All right, so we're sitting right there. Now we're going to basically go straight across and go to right there. All right, so we don't need G1 again, we just need the Z value, so Z 3.958, okay, and then we kind of repeat. We go to G0, I typed an O there, G0, and X 10 thousandths more, so 0.43, then that number right above me, a Z of 4.542. Okay, I don't even need to look at the drawing really on that one again. And then I go straight down, so it's G1, it's cutting. And I know my X is going to be, no, now I'm right here. So now I'm going to G2 actually. So Now I'm gonna cut this out with a loop. Now you could draw a straight line down here and put a dimension right here in the middle, and I actually might have done that first time we did the hammer, and you could go straight down there and clean it all up with a finish cut. But it's less coding to not do that, so that's why I quit doing that. We're basically going to do a G3 because it's clockwise, and so a G3, and we're going to go right up to here, okay? We'll back up there a little bit, and this becomes G3 since it's counterclockwise, and we're going basically to the same place we were before, X of 0.42. Okay, we're going to right here, all right? X of 0.42. And Z value of whatever that thing is, 3.958, same place we went to before. Okay, Z of 3.958. Okay, so we're basically went right above here to straight right over here with a round cut and one hit there, and then we need an R value on that. And the R value is right here, right? R is 0.99. Okay, because it's a G, it's a radius cut, so it's got to have an arc cut, so it has to have that. Okay, so now we've done the first one, and we're right here. Now I lied to you. We're not going to the 3, but I didn't do it on purpose, though. We're not going to 3.958. We're going all the way to here, because then we got another radius cut around the top of this thing. So instead of 3.958, it should have been 3.851. So back that thing up. 3.851. Okay, on the Z there. So now we're sitting up right here. It's 8 o'clock in the morning, so I'm going to make a few mistakes here. Now we're going to do across the top of this one, and that one is counterclockwise, so that's a G2. Okay, so G2. And the X, I think, is going to, and it's not, I'm really messing it up today. So that's not 0.42 either. It's higher up. It's right up here. So it should have been 0.46. We'll fix that. All right, so the G3 should be this one, all right, 46, because we went all the way up to here, okay? So make sure you got the right number there. I retyped it 3 times, third time's charm, and then you're going to 46 again. So you might not have to put in 46 on some machines, but I usually, on G2s and G3s, I usually put them in because it can screw them up on some machines. So 0.46 again. So we're going right over the top of this thing, right back down to here. And the Z value is whatever that thing is right here, 3.649. 3.649, okay? And we need the radius of that one, and it's this right here. 1.92, right? It's sitting right there. So the radius of R of 0.192, okay? Now you're sitting right here just like you were sitting right here before, okay? So the codes are exactly the same, except, well, I'll make it too easy for you. They're an inch less in the Z. So try to type them in and then compare to what you have before, and just see if the Z, see if it's identical, except instead of being 4.649 and 4.52 and 4.52 and 3.8, make sure these are an inch less. Okay, because if I remember right, that's how I drew this thing up. So like this one's 3.52. See if you look at these numbers. This one's 4.52. Remember we drew the circles an inch apart? So that makes it really easy programming. So that number is an inch more than that one. That one is an inch more than that one. So all the Z values should be an inch less. So you try to program it, and I would rather you try to program it so you get it in your head how to do this. That's what you're supposed to be learning in class. You're going to have to do it on the test by yourself. So just write those codes for this one. And then when you get that one done, it's exactly like this one, except Z's are an inch less. So it's easy check, okay? Then that one's done, this one's an inch less again. And then that one's done, this one's an inch less again. Except on this last one, instead of going up to here and doing a radius around the back, you're just going to go straight up to this point, okay? And at that point, we'll go back into the finish cut. So I'm going to give everybody a few minutes to do that, and then I want to see it on the virtual machine before we move on, okay? So I'll give everybody a few minutes to do that. All right, so I'm going to do one on the video just to show you. So I was right here, and now I'm right here at right at this point right here. So I'm going to go down to the diagonal again. Now it's a G1 again because I'm cutting material, and I know I'm going 40 less, so it's 0.42. Okay. Oh, I'm going straight across, actually. I'm already down here, so I'm going straight across. But it's still a G1. So when it's just a Z value, straight all the way over to here, 2.82. Okay, so it should be just like this one, except one less. So 2.851. Okay, so it's identical to that, except it's, I did have to type G1 here because it was a G2 right before that, so it's just like that one. All right, then I go down. Now it should be just like this one, but back and an inch less. I'm standing right here. I'm going to go back 10 thousandths into the same place I was before. So that's a G0 and an X 0.47 and a Z value of 3. I'm just looking right up here at these numbers right here because that's where I was before. Okay. 3.649. Okay, but now I'm going to check it up here and see if it's identical to this one, but an inch less, and it is. I know I did it right. Okay, same exact code, except it's an inch less on a Z. Okay, I'm going to go down here. Now I'm sitting up here. Now I'm going to go down to this diagonal. Okay, so it's a G1. I'm cutting material, and an X of 0.42, 40 thousandths less than the 4.6. And a Z value of 3.542, 3.542. Okay, now I'm going to check it, see if it's the same as this one up here. And it is. So I know I did it right. You just keep doing that, okay? I did verify with optional skip to make sure I didn't make a mistake, and it does seem like it's working good, so that's good. Okay, I did put a space between my coding lines, so I can kind of see what I'm doing in here too as well. Okay, if I have attention just for a minute. So I programmed all the way to this position right here, this 8.851 at 0.46, okay? The radius, okay? This is the last loop. Remember, it doesn't. This one's not the same. Now it doesn't go into another loop and stops. You just go straight up here. Okay, so we're going to go straight up here, and then we're going to go. Then we're basically going to go back to the safety position. So you can go to a couple places here, but I'm going to go all the way up to 5.1 right there. So I did that one. I'm sitting right here. So after that code, I'm still I'm done cutting material. It's all the way. There's still a little material right here, so I might as well take that out. So that should be a G1, right? Well, actually, instead of going right here, we should go, the G3 should go all the way up to this position, okay, because there's a little, remember we came across here and cut this off, so we're going to go all the way up to 755 on this last G3, okay, so I'm going to rewrite that one should be 755, okay, if I can type. Alright, so I go all the way up to here, to this position right here on this one. And then I'm basically out of the part. So that's also a 0.51 in the X. Okay, so 0.51. Okay, so your last line of code in the part should be that. We basically went from down here all the way up around here to this with our G3. One line of code brings it all the way up there. And remember, when you're cutting them on over the tool, there will be these little, you can't see them on your, you'll see them when you're running it, but there will be a little chunk left in this, and there's a little chunk left. That G3 is just going to clean all them off. Okay, it's just going to clean them out, just almost like a finish cut. Okay, so we're sitting up above that part. And when you get that done, we're going to do the finish cut. So I'll get started with that in just a second. So at this point, you'd want to test it and see if it's right before you go do your finish cut. So you turn your optional skip on first, and then you go to verify. It's probably a good idea to save it first. Save. I just saved over the top of my template file. Save as. And we're going to call this hammer handle. Later I'll go delete all those ones. Hammer handle, right? Okay. And then I'm going to delete them and put them back. Okay, so you want to test it after you do optional skip, verify program. Number's missing. All right, so make sure if you got an error like I do, it really had a problem here. I had the wrong one open is why. I thought I opened it. Where'd it go? Try again here. Verify. 201's inserted. That's how it should look. Did awful fast there, but okay, so it should look like that if you did it right. Nice clean cuts. Okay, now the finish cut isn't done yet. Okay, now I've got a few extra lines of code in mind to finish it out. on the template. But it basically went all the way through fine. Okay, that's what yours should do the same. All right, so if you're running a problem, make sure you have a window open to machine info. Mine didn't open with when I opened the system, so make sure that's open because that's going to show your line numbers. And of course, you want to renumber it too. So you would want to go over here to edit and hit renumber. Okay, you just say do it, and it'll put lines in there. Okay, that's a little annoying, but it helps you troubleshoot it a lot better. You can always renumber when you're done too. Okay, with those lines because they'll show up here on the machine info, and you can see exactly where your error is at when it brings up an error. Okay, so I'll say I left out a put a space in there accidentally. It's going to find that one on line 40. Verify window. That worked fine. And it's got a big error right here. It says missing numbers, so I accidentally put a space in there. So I know it's right on line 40. It tells me exactly where it's at. Sometimes it's the line before it causes the error because maybe the radius doesn't work or something. Okay, so then I do OK, and I go back to line 40, and I figure out where I made a mistake, and there's a space. Fix it, resave it. So make sure that's open if you're troubleshooting. Okay, so we're ready to go again. So we've got all the way up here. We've got all the rough cuts done. We got our finish cut next, and it's pretty easy. We'll do that together, but on the video here. So I've got all my codes down here. Yours should look just like mine, basically. And I don't know if I was perfectly clear on all these. So this one should be 1 less on the Z. This should be 2 less on the Z. And the last one should be 3 less on the Z. But otherwise, they're very similar. The only difference is this last one has less codes because we're going all the way up to here instead of doing a loop-de-loop around. And they're all different a little bit on the first one because it was a G2 to here and then a G1 going down here. And those were just G1s going down all together on the first one. Okay, so let's do the finish cut. So we're sitting up here at this spot. We need to go, and we could have just went like up to 5.0, but I wanted to be above the part when we're going back, so that's why I went up to 0.51. Okay, so now we're just going to go straight back all the way to the very beginning again. Okay, so that's way back here, and we might as well go back to 4.75 so we can go straight down on the part and start our finish cuts. So that'd be a G0 because we're going to go high speed. And we're going to go all the way back to 4.75 in the Z 4.75. Okay, so now we're sitting right here, all the way back, right above the part. Now we're going to go down. Now you're probably not going to hit the part of this, but still should be a G1 just in case. So G1, and this is our finish cut, so we want to slow it down to F4. Okay, so G1 straight down to 5.0 on the X, so X 0.5. Okay. Not 5.0, 0.5. And sometimes people add O's for real old machines like 2 digits. Really, really, really old machines. So X 0.50 brings us down to right here. Okay, now we're ready to do loop, diddy loop, diddy loop, diddy loop till we get done with this thing. All right, all the way through. And I forgot to hit F4. F4. We gotta go slower. Finish cut, we want it to go slower and look a lot prettier. You can even slow it down more like an F2. And sometimes they'll speed the RPM up, and that'll actually give it a nice finish cut on there. You can buff it with a buffer and really make it shine like a piece of chrome, basically, if it's that aluminum 6061. Okay, now we do our loop-de-loop. So the first one's going to be counter or clockwise, so it's a G3, of course, right? So G3, and I got X value first. We're going to go right here. Now remember, we're reading the numbers on the bottom now because we're doing finish cuts. So 3.8, oh, that's the Z. I think it's 0.46. That's what it should be. If I did this right, it looks like it is. I'm going to zoom in a little bit there. Try to. It's all the way zoomed in, so I guess I'm not going to zoom in. Okay, and you can't see the little node on there, but it's got to be at 0.46. So my X is 0.46. Okay, and my Z is 3.827. Okay, my R value is just 1, right? Got to put the R value in a 1.0 just to be safe. Okay, now we go to G2 because we're going counterclockwise, going back over to this position. Okay, so these will all be just basically repeats nonstop on here. And I could have put a space between there. I kind of like to do that so I can see where my codes change. So I go up there and do that. So this one's G2, and it goes to 0.46 again. Everything's going to be 0.46 on this, I think. So that's X of 0.46, and a Z of bottom number 3.673. 3.673. Okay, so we're sitting right here. And now it's just one number less. So I don't even really need to look at it. It's good to do it, I guess, to kind of get your head in there. But we're basically going to go to this one and back to this one. Okay. So I'm just going to keep typing them in there. So that'll be a G3. And just look above point X or X of 0.46. A Z of 2.827. And I need the R value in there, R1. Now, I think it might remember the R value is modal, but no, I wouldn't risk that one. G2 of X 0.46. A lot of repeat here. Z of 2.673. Okay. We went over to here. Now we're going back down to here, right? And we're going to go back over to here. And then we go G3 again. X of 0.46. Z of 1.827. R1. And I forgot the R values on these G2s. That was a mistake. So that was an R value of 182 on the bottom. See that right here? So we need to make sure you put that R value on the G2. I left that out. 1.82. R 0.182, it's a small radius. And this one as well. R 0.182. They're all the same radius. So. And there we go, G2 there. X 0.46. Z 1.673. 1.827, 1.673, R of 0.182. Some of you are a lot faster typers than me, I'm sure. But now we're here. Now we're basically right here. Now we're going to go all the way up. Okay, so this one's a little bit different. It's counterclockwise again, so it's G3. And the X is all the way out to 50. So X of 0.50 and a Z of 0.75 all the way to here. This is very important. You got this number in here, right? Because the machine is right here. So if you go too far past 0.75, I think the machine starts at 0.625. So even if you go a little bit just a little bit past this, you're going to clobber that machine and it's going to break it. It'll literally break the tool off and tear things up. So you want to be really careful that you never go into the chuck with the tool. The chuck's hardened steel. Usually you don't want. Well, it's just not designed to be hit with a tool. Z 0.5. Let's see here. Z 0.75. And that's the end of our finish cuts. It's got a radius of 1 again. 0.0. Okay. And okay, so let's test this thing out and see if it works. All right, so if I program, make sure your optional skips on before you hit that, of course. Tool 1. That looks good. Did a nice clean job. I don't see any nicks in it or anything like that, so all looks good. Give you a minute to finish that up. All right, so the next part is a lot easier. That was actually the hard part we did first. So now we got to flip this thing over because it's 12 inches long and our machine only did about 7 inches. So we got to switch it over. So if we go over to the lab, I pretty much told you what those codes are because I didn't want you to make any mistakes. So in between where your template's done and where you just got done coding, we need to stop this thing. So we need to shut spindle off, go to the safe position of 2 and 4. We need to pause it. Okay, M0 will actually stop the coding. It won't actually go any farther until you hit the enter or basically the green button to go farther. And then these little codes on this machine That stands for accessory number 1. It opens the door, so it's basically a plug-in, all right, on our machines, and on a lot of machines it is too. Sometimes it's a lot of times it's a 120 volt outlet. It'll just turn on and off with a relay, okay, from a PLC. And that's a lot of times what it is. M8 usually turns the coolant on, but our machines don't have coolant, so it just opens the door. And M9 usually turns the coolant off. On this one, M10 is another accessory. It actually opens the chuck. Okay, so one will open the door so you get your hand in there, one will open the chuck. Then it'll pause again and stop coating. And that gives you time to put your hand in there and flip it. Didn't have this. If you miss this M0 in there, you won't be able to get your hand in. It'll just go right on the other one and shut the chuck and shut the door. And I've had multiple students write this straight on through without that M0. And it just opens the door, opens the chuck, shuts the chuck, and then it keeps on trucking. Okay, so I put a couple extra pauses in here in case they make a mistake. That's kind of why I have these in here. Then it's going to close the chuck and it's going to pause again. Make sure you're happy with it. Then it's going to, because you got to kind of hold it in there to close the chuck so it's tied up against there with your hand. And then it's going to pause and say, okay, are you done with that? Say yes, and then it's going to close the door. And it's going to pause again to make sure everything's good. And then it's going to turn the spindle back on, spindle speed up to 2,000 RPM, and it'll be flipped over. We'll start writing the rest of the code. Okay, so type all that stuff in. Okay, I'll give you a few minutes to do that. All right, so I've got all those codes in there. All right, so now we need to basically, this thing's flipped over, okay? So now we need to basically program the other half. The other half's a little bit easier, actually. That was the hardest part, okay? So we're going basically up to part 2 now on drawing, right? Way up here, okay? Let's go through this one real quick, too. Control minus. So what did I say to do here? Okay, so you're going to all that. You flipped it over. It's in the safe position. Spindle went back on. So it should be at like 2.4, okay? Because that's where we total right here, okay? And then we're basically going to be going back into the part. So we're sitting up here about this area right here. We need to go back over to this part right here and just ignore all the stuff back here because it's all done, okay? We're basically going to be up here. And the long-range plan is, you can't really see it very good, but we'll zoom in as we go. We're starting up here 10 thousandths above 0.51 again, at whatever number that is, 5 or something. And we're going to go diagonal to here to G1. Okay, so we'll G0 down to the safe spot. And then we'll go diagonal here and then straight across and 10 thousandths back to here. Then diagonal down to this one, straight across 10 thousandths back. Diagonal here, straight across 10 thousandths back. And I think it's diagonal the rest of the way. Then you go straight up and cut those things off, the little nubs. Don't even really need to do that. I don't think you could do it on finish cut just fine. Yeah, so we'll just come 10 thousandths above here again. And then we'll go down and slice all the way down here and clean it up. Okay. I think this long of a diagonal with only 10 thousandths is probably good to go straight up and back. I usually would tell you not to do that. But on the rough cut, just go down when you do the last one down to this. Go straight up, cut those nubs off, and then come straight back. Just because if I remember from past experience, when we went backwards that long of a distance, 10 thousandths, it zigs a lot all the way back there because it's really not enough over the 6-inch path. So then we'll come down and we'll do our finish cut over it, okay? And this is going to be cut off with a saw anyway right here, but on the part, so hopefully not where we machine. All right, so let's go ahead and do it. Let me zoom in. Starting right there. Remember, we're using the numbers above the part if we drew it right. And we're after this, spindle's back on. Not sure why we've got an extra line in there. They just do. All right, get rid of that line. Okay, and I'm gonna put another space down here because I always like having a space between everything, so you can see what it's a good idea to have that when you're programming. Easier to troubleshoot. All right, so we're going down to 650, and I don't see that number, but I know what it is. It's 0.51, right? And we got a high speed to it. So G0, and these are all M0s, not MOs, by the way. Okay, G0 X 0.51. These are all the same numbers every time on our machine. Some machines might be able to take off more than 40,000, of course, but it'd still be a similar process, so you could memorize them. 5.1 and 6.503. And my Z. Z is 6.503. Enter. And we just did our finish cut, so our first, a lot of times people forget this one, and I a lot of times forget it too. We need to change our speed back up, or the whole thing's going to go slow, and it'd take 1,000 hours for 20 people to run it. So we definitely got to go change our speed here when we do it. All right, so we're sitting up there at the part, and we've got to go a little minus there so you can see them both. So we're sitting right here. We're going to go down to this, and it's 0.46 because it's 40 drop, right? Yeah, it's 46. Yeah, I always forget that I'm 10 thousandths above it. So, okay, so G1 X 0.46 and a Z value of 4.809. 4.809, and there's no loops in this side, so it's pretty easy again. No circle interpolation, and we do have a F value on this first line of code of 6 because we want to speed it back up to 6 inches per minute so it doesn't take all day. All right, then we got to go back 10 thousandths high, so G0 X of 10 above 46, so 0.47, right back to where we were, of Z of right up here. So this is actually, I lied, so it's that number, right? We're at 4.6. We don't just go 10 up, or we'll be basically going straight back and cutting that off. We don't want that. We go back to where we were before, 10 thousandths above. Which, since this was in the safety thing, we're just going. Probably should have maybe went down at an angle to it, but it's still fine. So 0.51. We're not going very far back anyway. And 6.503. I'm changing the wrong numbers here, aren't I? Sorry. It was 4.6. And the 4.7 after the G0 should have been a 5.1. Okay, so we're going from here back up to here. And probably ought to do 5.2 just to be safe there. Boy, it must be a Monday. I'm really losing my mind. So we're not going back yet. We went down the diagonal, and now we got to go all the way across and cut that off. Okay? So it's not going back up yet. We go back up after we get all the way across. I knew something was fishy there. It's been a while since I did this. So we go straight all the way across here until we get to this, which is, I think since it was cut off of the saw, I just left them all go to 0.75. Okay, because it's going to be saw cut off anyway. So we basically go, it's still in G1 here where I did that G0. So back it up. And you can leave. You don't need to type in G1 because it's a G1. And height is still the same, so we don't need to type in X.46 either. Just type our Z value of 0.75. Okay, and it's going to go straight across there up 6 inches per minute until it gets all the way to here. Okay, so we're sitting right at that. Now we go 10 thousandths high. Okay, so this is a G0 high speed, 0.47. Knew something was going on weird when I started typing there. And that is my X value, X of 0.47. And the Z is right back to where we started out, up the 2 lines up. Okay, so Z 4.809. Okay, enter. Now we're going to cut down, so it's G1. I know it's going to 4.2 because we're doing 40,000, so it's X of 0.42. And then I got to go back over here and see where it is. We did that first one to there. Now we're going to do this one. Okay, so we did the 408 last time. So we're sitting up here at 408, at 4.7 up, 10 thousandths above it. Now we're going to diagonal cut down to this one. Okay, so that would be a Z of 3.56, 3.456. Sorry. Okay, and then we go straight across again. And we don't need to change height, so it's just a Z value, and it's 0.75, same darn spot. Don't even have to look at it. Going back to where that handle's going to be cut off. Okay. Now we kind of repeat the same process again. G0 high speed. Going back to 0.43 because it's 10 higher, so X 0.43. And a Z value of right back where we were, 3.5457. 3.457. Okay. Then we go G1. And the X value is going to be 10 less or 40 less again. So X 0.38. See where we're at here. Getting pretty close to getting this one done. How low do we go on this thing? Goes all the way down to 3.4, but that's on the last diagonal cut. So this will be the last one straight over. Okay, so we do a Z of, we're sitting here, this is 3.456. We did a diagonal down to 3.8. We need this number in it. So 2.103 is the Z number, Z 2.103. Then we go straight over again, just 0.75, so Z 0.75. Okay, and then we go G0 right back up again. X 0.39, 10 above, and the same number we were before, 2.103. Okay, so now we're 10 thousandths above it right here. Okay, we didn't drag our tool back, and now we're basically almost done with the rough cuts. So now we're going to go G1. And we go X of 0.34, okay, and a Z value of 0.75. It's actually all the way over there now, 0.75, okay. All right, so we're all the way to this position right now, and we're basically done with it. Now, like I said, typically we would go 10 thousandths back and drag it all the way back, but I remember it's such a long distance, it gives it kind of a corkscrew look on it, so we don't want to do that. So we're going to go straight up to 5.1 and then straight back. Or we'll just go 5.0 because this is all gone. So we can go to 5.0 and we'll be in the right place to begin with when we go straight back. And there shouldn't be any material there, it should be safe. Cut like this, either way would be right. So straight up is, and it is cutting some material going straight up here. There are some nubs on there, so it's G1, and we're going to go up to X of 0.50, okay? And then the next line is going to be Z straight back. And this is going to be high speed, so G0 on the next line, okay? You have to write that in there. And we're going all the way back to where we started, but now we're using finished cut numbers. We're on the bottom, so 6.5, okay? I guess to be safe, maybe we'll put, no, we want to do finished cuts, just leave it like that. All right, so G0, 6.5, and the Z. Okay, so now we're sitting right at this place. Now we do our finish cuts, and this is the shortest finish cuts ever, right? So it'll be G1 all the way back to where we were pretty much, except it's 330. So X 0.330 and Z of 0.75 again, and we got to slow it down to F4, right there. We went all the way from the top all the way down here, and now we're going to go straight up again, just to go hit it one more time and clean it up. You could go G0 there, but it's probably safe to go G1. Either way would probably be fine, but I'm going to go G1 just to be a little extra safe. And that goes up to 0.5. And that'll finish it up and clean it up a little bit. It is a saw cut, so it's really not critical. So, but G X of 0.50. Okay. And our last code should already be in there if this is our template. So it's going to shut the spindle off. So it's just going to stop it from spinning and stop cutting. And then it's going to go get the heck out of there. It's going to go to 2.4. I'll say in the program. Okay. So now it's going to have both those cuts in there when you watch it. You can try to use the reset thing on this. Sometimes it works, sometimes it doesn't. And just see how it goes. All right. So it's probably a good idea to save this. Because the problem is say you left your decimal place out of this. Say I did 2.103 there, and I left that out, and it's 2,103. It'll actually try to go 2,000 inches high, and it'll be so slow that it'll sit there for a year. If that ever happens to you, you can hit plus a bunch of times, and it'll eventually get through there. But it won't air out. It'll think it has to go that high. So it's a good idea to save, because then if you have to do a Control-Alt-Delete, you can get your program back. Because on a machine, it'll never get there. On the CNC machine, it'll basically sit there and try to go up there forever, and it won't stop. But well, it'll lock up probably first. But all right, so verify program. See if I made any typos. Okay, now we're doing all the flipping over. Pause, open, shut. Pause is open the door, close the door. Go back on. Yep, that looks right. It's pretty fast there, but it looks right. Diagonal through there. Up. So slow it down a little bit and watch it when you're doing it. Make sure it's right. I'm going to do the same thing. So, verify program. So if you see any notches or straight cuts or anything on that first handle, it's definitely got an error in it. Should be nice and smooth like that, and do all the flipping. I'll go across there, down a little bit more, Finish cut it out. Looks good. All right, if your first worked, save it. And I think that's the end of the video. Let's see if anybody has any questions. If not, then I'll shut it down here in a minute. Okay, make sure you turn in the drawing for this and this program for the slab. The next slab, I think it's 871 or something like that, will be where we do the threading.